Hello students, welcome to the Rankers Academy. मी योगेश्री. फिजिक्स लेक्चर सिरीजच्या सेकंड लेक्चर मध्ये आज आपण बघणार आहे किर्चॉफ सेकंड लॉ. किर्चॉफ सेकंड लॉ is also known as voltage law. Now first we will see the statement of Kirchhoff's second law. What Kirchhoff's second law states that Kirchhoff's second law states that the algebraic sum of the potential difference. Now potential difference, as we know Ohm's law, potential difference includes the current and resistance, the combination of current and resistance. So the algebraic sum of product of current and resistance we can say, and electromotive force. Electromotive force means EMF in a closed loop is zero. So Kirchhoff's second law states that algebraic sum of potential difference and EMF is equal to 0. So the mathematically summation, that means algebraic sum potential difference is the product of current and resistance, V is equal to I into R, plus algebraic sum of EMF, E is equal to 0. Now we have to prove this mathematically. How to prove this mathematically? We should know that to prove this mathematically, we should know the sign convention for Kirchhoff's second law. Now we will see the rules for the sign conventions that we should have to follow. See, there are two different terms used in the Kirchhoff's second law. The first term is the potential difference and the second term is the EMF. For potential difference, there are different sign convention, and for EMF, there will be a different rules of the sign convention. First, we will learn the rules for the potential difference. First rule, while tracing the circuit, there is a simple electrical circuit, any electrical network you can consider, and when you are tracing any electrical circuit or any electrical loop, if we are traveling along the direction of current, the tracing direction and the conventional current direction is the same, then the potential difference can be considered as negative. You have to give a sign negative, minus sign. When you can give negative sign, if the direction of conventional current and the traveling direction both are same, then you can use the negative sign. And the second rule is exactly opposite. While tracing the loop, if you are traveling against, that is opposite to the conventional current, then you have to give a potential difference as a positive. If in a similar direction you are traveling, consider negative. In opposite direction you are traveling, consider positive sign. Then EMF साठी तुम्हाला सेपरेट साइन कन्व्हेन्शनचे दोन रूल्स दिलेले आहेत. आता EMF चं साइन पॉझिटिव्ह कधी घ्यायचं आणि निगेटिव्ह कधी घ्यायचं. सी, the first thing is, if you are tracing the circuit, EMF means battery. Suppose if you are tracing the circuit from negative terminal to positive, तुम्ही negative कडनं positive कडे चाललाय, you should have to take positive sign. See, if tracing the circuit from negative to positive, always you should have to consider the second sign. ज्यावेळेला तुम्ही सर्किट ट्रेस करता, त्यावेळेला सर्किट ट्रेस करताना बॅटरीचं जे सेकंड साइन तुमच्या येतं ते तुम्हाला कन्सिडर करायचं आहे. जर निगेटिव्ह टू पॉझिटिव्ह जात आहे, पॉझिटिव्ह साइन कन्सिडर करा. अँड इफ यू आर ट्रेसिंग द सर्किट फ्रॉम पॉझिटिव्ह टू निगेटिव्ह, देन यू हॅव टू कन्सिडर निगेटिव्ह साइन. सो दिस साइन कन्व्हेन्शन वी शुड हॅव टू अप्लाय फॉर electrical network. By using this sign convention, we can simplify any complicated electrical network. Here I have taken a simple electrical network. Now see, there are different junction points, two loops I have considered. In this electrical network, two different loops are there, and these two different loops has been combined by two junction points, that is B and F. In this electrical network, there are total 5 resistances, R1, R2, R3, R4 and R5. Also 2 batteries are considered, E1 and E2. So this will be your first loop from which the current flows, and this will be your second loop from which the current flows. For both the loop, if you have to apply this Kirchhoff's second law, you should have to apply the sign convention. आता हे साइन कन्व्हेन्शन आणि हा किर्चॉफचा सेकंड लॉ, हे दोन्ही अप्लाय करून हे जे इलेक्ट्रिकल नेटवर्क आहे हे कशा पद्धतीने सिम्प्लिफाय करायचं हे आपण बघणार आहोत या व्हिडिओच्या सेकंड पार्ट मध्ये.